Welcome to Built, Wired, and Secured. I'm Alex Morgan. In today's episode, we're discussing risers and reroutes, preventing single pathway failures in modern buildings, what it is, why it matters, and what decision makers need to know to avoid costly mistakes. Joining me today is Michael Harrington as we break down real-world lessons, common challenges, and practical takeaways you can apply immediately. Let's dive in. Imagine a contractor cutting into a wall to run a new cable and accidentally severing a single conduit that held the main communications trunk for half the building. Elevators stop, security doors fail, the point-of-sale systems go dark, and tenants can't operate for hours. Who makes the decision to route that riser? Who pays for the outage? Who gets the call at 3 a.m.? This episode is about preventing that scenario before it happens.
From an operational standpoint, that scenario is all too familiar. Tenants feel this immediately, and the downstream impact is costly and reputational. Today, we'll walk through how risers and chases become single points of failure, and what practical steps owners and ops teams can take to harden them.
First, let's define terms and explain why these physical pathways matter. Michael, tell us what we mean when we say risers, chases, and conduits, and why they so often end up carrying a mix of power, data, and low-voltage systems.
A riser is the vertical route inside a building that takes systems between floors. Think dedicated shafts or stacked closets. A chase is similar, but can be horizontal, between zones, or through ceilings. Conduits are the physical pipes and cable trays that run within those spaces. Because space is limited and teams are trying to reduce cost and complexity, architects and contractors often place multiple systems in the same route. Power feeders, telecom trunks, fire alarm wiring, and control cabling for mechanical systems. When those systems share a pathway, a single breach or failure can cascade across multiple services.
What are the common failure modes you see when these pathways are treated as shared resources?
There are a few repeats in my experience. Physical damage during renovation or drilling, water ingress in a single chase that wasn't sealed properly, a single cable crush point in a conduit, and improper segregation of high voltage and data that leads to interference or failure. And then there's the human factor, documentation that shows one pathway but not the actual as-built routing, which leads teams to assume redundancy that doesn't exist. That combination is how a small event becomes a building-wide outage.
Let's move to causes and trade-offs. Why do these single pathway designs happen in the first place, and who is usually making those choices?
Most often, it's a mix of cost, space constraints, and schedule pressure. Developers and architects aim to optimize rentable area and are sensitive to the extra square footage risers consume. Contractors pick the path that minimizes labor and material cost. IT and security may be brought in late after pathways were laid out for electrical. If responsibilities aren't clearly assigned in the contract, the path of least resistance becomes the default. That's fine until it fails, and then you find out who owns the recovery bills and the tenant complaints.
So there are trade-offs between upfront cost and long-term resilience. How should teams weigh those trade-offs during design and procurement?
Prioritize critical services first. Ask, what breaks if this goes down? Map which tenants and operational systems depend on each pathway. Then use a risk-based approach. For the most critical services, require physical separation or redundant routing in different shafts. For less critical circuits, document agreed risks and mitigation, like rapid response spares or temporary bypass plans. Include those requirements in the tender documents, and verify them at handover with as-built drawings and physical inspection.
Let's talk operational implications and response. When a pathway is compromised, how do outages typically play out, and what should teams practice ahead of time?
Outages often start small and escalate fast. A damaged conduit can knock out a comms trunk, which affects access control, then the entry gates, then tenant services. From an operational standpoint, the first hour is triage. Isolate affected systems, assess safety impacts, and communicate to tenants. Tabletop exercises are valuable because they expose coordination gaps between facilities, IT, and vendors. But real incidents reveal different constraints. You need tested escalation paths, pre-negotiated vendor SLAs for emergencies, and a single incident commander to coordinate trades. That reduces duplication and speeds recovery.
Do you recommend any simple drills or validation steps teams can run without major disruption?
Yes, validate your as-built routing annually with a physical walkdown and updated diagrams. Test failover plans for critical services and run a mock contractor scenario where a wall is opened and your team practices protecting the riser. Those checks are low cost and catch assumptions before they become outages.
Michael, can you share a concise real-world lesson where a pathway failure taught a durable fix?
Sure. We had a mid-rise office where the primary telecom trunk was routed through a single mechanical chase to save space. During a refurbishment, a contractor accidentally crushed the trunk behind a wall, taking out phone and network for 3 floors. Tenants were offline for most of a business day. The fix was threefold. First, immediate tactical response, temporary wireless links and portable access points to restore critical services. Second, a medium-term splice and protected reroute in a different shaft. And third, policy changes. Every renovation now requires a riser impact sign-off, labeled pathways, and a clause in contracts that requires notifying building ops before any wall penetrations. Those changes cost less than a single day of tenant downtime and reduced repeat incidents.
That's a clear example of how a small design or process gap can create outsized operational risk. Let's wrap with practical takeaways. What should listeners do differently starting tomorrow?
Start with an audit. Map all risers, chases, and main conduits. List which systems each contains and which tenants they serve. Label everything physically and in your drawings. Prioritize critical systems for physical separation or redundant routing. Add a riser responsibility table to handover paperwork that names owners and maintenance contacts. Include a riser impact check in any renovation permit and require contractor coordination with facilities. Finally, run simple tabletop exercises to validate incident roles and escalation.
For listeners, we've built a downloadable riser audit checklist with labeling templates, a sample riser responsibility table, and a short permit checklist you can add to renovation scopes. Visit the show site to grab that resource and share it with your teams. That wraps up this episode of Built, Wired, and Secured. Today, we explored how shared risers and conduits can become building-wide single points of failure, and why owners and operators need practical controls, mapping, labeling, contract clarity, and simple tests to reduce risk. Thanks for spending a few minutes with us. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world.